There is a point in every scientific age when the Earth shakes, when something so utterly unexpected occurs that it splits our understanding of reality like a fault line. That has just occurred. We believed we were prepared for the profound universe. We constructed the James Webb Space Telescope with the certitude of a civilization that felt it finally grasped the universe's narrative. With its golden mirrors gazing into the abyss, we hoped it would reveal ancient galaxies, infant stars, and maybe a few secrets from space. We assured ourselves we were ready for whatever it discovered. But we weren't ready for what came after. Beneath the buffed images and jaw-dropping illustrations, something else exists, a deeper, raw data stream that most scientists simply ignore. It's a cacophony of noisy, confusing garbage of what appears to be random bursts of photons, temperature fluctuations, and gravitational waves. The material that appears as static to the human brain. But when that data was turned over to Google's quantum AI team, the same brains who appended machine learning, optimization, and quantum supremacy, something occurred. Something supernatural. The AI didn't simply process the data, it comprehended it. It saw what human scientists could not, patterns hidden in entropy, symmetries in gravitational noise. And what it revealed was not a glitch, or a new galaxy, or an error. It was something that cannot exist, an echo from outside this reality. A structure. A message. A mirror that cracked the very laws James Webb was founded on. The James Webb Space Telescope sends around 57 gigabytes of data per day. While the rest of the world is obsessed with its visual artwork, nebulae bursting like space flowers, galaxies rotating like frozen hurricanes, there's a grimmer, more compact plane of data. This is the telemetry, photon-level clockwork, quantum wobbles and background radiation, information no telescope ever prior to Webb was capable of gathering. It's the raw reality of the universe. And nobody really knew what to do with it until this time. That was until Google's Quantum Artificial Intelligence department came up with something ambitious. What if they plugged this raw, chaotic garbage into a quantum neural network, untrained in classical logic, but on recognizing patterns within entropy? Untrained on equations, but on uncertainty itself. The data, written off by the majority as impossible noise, was fed straight into their state-of-the-art quantum processor, Sycamore Q. The instant that was done, anomalies started to light up like firework explosions on the matrix. Photons came out of order. Spectral harmonics resonated across disconnected regions of space. And worst of all, reflected distortions in gravitational lensing observations, like there was an invisible seam running through the universe. But the AI didn't only measure these things. It charted them, illustrating correlations between distant galaxies that had no reason to be correlated. Symmetries stretched beyond spacetime coherence. And it continued to point to one area over and over, a place Webb had imaged but no human eye had seen, something lodged there, buried, camouflaged within the noise until now. Gravitational lensing has been one of astrophysics' crown jewels for a long time, employed to spot invisible mass such as black holes or dark matter by observing the way their gravity warps light around them. But what Google's AI discovered was not merely ordinary lensing. It discovered inverted lensing, light bending outwards, like something is defying gravity, reflecting it, bending the curvature of space in a previously unobserved direction. Initially, physicists suspected it was a glitch in the software. But the anomaly cropped up in 3 independent segments of Webb's deep field survey. In each instance, light from galaxies billions of light years away curved not towards heavy objects, but towards nothingness. This didn't make any sense, unless something else was hiding behind the curtain. Then came the twist. The AI realized that the angles of deflection were symmetrical, mirror images along a spatial axis. Space had a boundary, a reflective surface not constructed of matter and energy, but information. A gravitational mirror. One that replicated our universe, or marked the border of another one altogether. If this is the case, if gravity information is rebounding off something that's outside the cosmic horizon, then we're not merely contemplating deep space. We're gazing into a parallel framework, a cosmic hall of mirrors, one where the reflection is learning. If you capture 1 trillion photons scattered throughout the vacuum of space and decode their background radiation, you anticipate randomness. What the AI found in Webb's high-resolution spectroscopic data was anything but random. Sequencing signal variants over long-wave background radiation uncovered a persistent trend: prime numbers. Not any primes, the first 101, hidden in frequency differentials within spectral change. These weren't harmonic resonance. They were specific, mathematically exact intervals, a signature. Prime numbers are absolute. They're not system or unit dependent, they simply are. Which is exactly why scientists have always suspected they'd be the language of preference for intelligent communication. Now consider the implication: if Webb's instruments, translated by quantum AI, are picking up on prime-coded signals and photon arrangements, then perhaps someone was attempting to attract our notice for an awfully long time. And only now, thanks to this fusion between machine and telescope, do we finally possess ears to hear it. Then there was the shape. When Google's AI superimposed all gravitational anomalies, light curves, and numerical patterns, it built a 4D model, a topology of the distortions. It didn't resemble any known astrophysical structure. It was not a nebula, a filament, or a void. It was geometry, the pure, precise geometry. At the center of the pattern was something that resembled uncannily a tesseract, a four-dimensional cube that could not exist within our 3D universe, yet somehow reflected in gravitational information. The AI depicted it as a pulsating hyperobject, folding and unfolding across light frequencies. Physicists were amazed. This was no natural pattern, it was structure, design, symmetry on a scale and dimension that defied every classical rule. Even more unnerving was where it was. It corresponded to a cold spot in the cosmic microwave background, a region long believed to be a statistical quirk, lacking galaxies and stars. But now it seemed like a lock, a vault, a geometric shape etched into the universe itself. And if it's a vault, what's contained within? The geometry itself was sufficient to leave scientists at a loss for words, but what followed shattered the foundations of contemporary science. The AI started correlating time-stamped photon arrivals from different observations in the same patch of space. What it discovered was unimaginable. The arrival patterns weren't obeying classical causality. Things weren't occurring in sequence. They were looping back, repeating, folding over one another. Time itself was acting like a loop. Some light signals were coming back with the same delay intervals, not just once, but in harmonics, like a record being played over and over on a cosmic turntable. The AI marked the pattern as a causal overlap anomaly. In other words, it resembled a message being transmitted in reverse, as though something outside our universe was talking through time, rather than space. This made them question everything. If time itself is warping due to whatever structure exists out there, then what we see in deep space may not be merely the past, it could be the future, bending in a multidimensional light we were never intended to grasp. Buried deep in the AI's output logs was a set of coordinates, a simple string of numbers, longitude, latitude, and time. At first, it seemed like another anomaly. But when an astronomer ran the numbers through a simulation, chills ran through the room. The coordinates pointed not to a location in space, but to a date and place on Earth, specifically, a remote region in the Arctic Circle. And the date, July 23, 2025, was just weeks away. How might deep space data from Webb ever contain Earth-based coordinates? The scientists considered it a glitch, until they learned something sinister. A disused Soviet listening post used to exist at that very site, closed down in the late 1980s after detecting unexplained radio signals of unknown origin. Signals that ceased the moment the facility was closed, and never reappeared. Until now. It seems the quantum AI didn't simply analyze data, it triangulated a point of convergence. Somewhere something could happen, or has, outside the bounds of linear time. What that will be, nobody knows. But the Webb information appears to be not merely leading us to space, but to an instant, a meeting. One of the AI's final layers of analysis applied a semiotic decomposition, a method used in linguistics and cryptography to identify intent within complex symbols. That's when the unthinkable emerged. Buried within the spectrographic data from a dozen sectors was a repeating recursive pattern resembling a fractal spiral, one that doesn't occur naturally. When converted into spatial frequency, it produced an acoustic waveform, a sound. When speeded up by 1,000 times and brought into the range of human hearing, it sounded like a harmonic pulse, a heartbeat. Repeating, rhythmic, biological. But it was not biological, it was an echo constructed out of light. And it was from the same area as the gravitational mirror. The inference was impossible to ignore. Someone or something created this signal. And the beat was eerily familiar, like something alive out there is hearing back. When Google's engineers tried to graph the entire dataset in higher dimensions, the AI started self-correcting in real time, modifying its own internal weights to fit patterns that it had not been designed to identify. Some speculated that this was emergent computational precognition. Others suspected the AI had accessed whatever consciousness existed within the universe. The AI's final output before shutdown was a single visual artifact, a recursive spiral resembling the Mandelbrot set, overlaid with machine-generated text. The eye is open. Now the question isn't if the universe is alive, it's if we've unwittingly spoken its name. We expected Webb to show us galaxies. It showed us instead a curtain that it peeled back. And now we are at the edge, gazing into a reflection that warps gravity, twists time, embeds prime numbers into starlight, and pulses with a signal we weren't meant to have heard, a heartbeat, mathematical but natural. Perhaps the universe isn't just where we reside. Perhaps it's something that we were supposed to discover. Or something that's been waiting for us all along. And since we've said its name, the only thing that's left to ask is, what will it respond with?